Using ESO's flagship Very Large Telescope, along with other telescopes around the world, a team of European astronomers has discovered the most distant quasar ever recorded. By studying this blazing beacon in detail, the scientists have found that we are seeing this quasar at a time when the universe was just 770 million years old. This means that the light from the quasar took 12.9 billion years to reach us. Never before has a brighter object been observed this far back into the early universe. Quasars are very brilliant, distant galaxies, powered by supermassive black holes at their centers. These amazing objects have the mass of millions of suns crammed into spaces as small as our solar system. Quasar phenomenon transforms ordinary galaxies into what astronomers have fittingly dubbed angry monsters, the most luminous of all objects in the universe. And ESO's Very Large Telescope, better known as the VLT, helped to discover the farthest of these impressive objects ever observed. Back in the early universe, galaxies contained much more gas and dust than we see in them today. Gradually, material was used up in the formation of stars and planets, and less was available to feed the supermassive black hole, the process that creates the impressive jets of a quasar. Objects far back in the early universe, like the newly recorded quasar, cannot be observed in visible light. By the time it reaches our detectors on Earth, the expansion of the universe has stretched the light so much that it falls mainly into the infrared part of the spectrum. Quasars in the early universe are extremely rare, and so in order to find this object in the first place, the team of astronomers had to spend 5 years painstakingly examining huge lists of objects from an infrared survey made by the Herbert telescope, before they finally struck gold. With such an exciting discovery, the team could take no chances. They had to validate their findings. Using the Force 2 instrument on the VLT, along with instruments on the Gemini North telescope, a redshift of 7.1 was confirmed. This corresponds to such an extraordinary distance that it took the light from the quasar 12.9 billion years to reach us. Despite the vast distance, the quasar's extreme brightness made it possible to identify other characteristics using the same two telescopes. It was determined that the black hole powering the quasar has a mass of about 2 billion times that of our own Sun. This is an extraordinary mass for an object so early in the universe. Since current estimates say there should only be around 100 bright quasars at this distance across the entire sky, finding this object was a huge challenge. It was a great bonus that it has proved to be even more distant than the astronomers expected. This quasar is a vital probe into the early universe and will help us understand how black holes grew just a few 100 million years after the Big Bang.
A team of scientists has studied the unusual galaxy cluster Abell 2744, nicknamed Pandora's cluster. Using telescopes in space and on the ground, including the NASA ESA Hubble Space Telescope and ESA's Very Large Telescope, they have discovered that it was formed by the simultaneous pileup of at least 4 separate galaxy clusters. When huge clusters of galaxies crash together, the resulting mess is a treasure trove of information. Observing these cosmic pileups lets astronomers reconstruct events that have happened over hundreds of millions of years. It also lets them study how different types of matter behave during these collisions. The galaxies in Pandora's cluster are clearly visible in images from Hubble and ESA's Very Large Telescope, but they only make up about 5% of the cluster's mass. About 20% is hot gas, which is shown here in pink. This gas is visible thanks to its X-ray emission, which can be detected with NASA's Chandra satellite. The lion's share of mass in the cluster, about 75%, is dark matter. The dark matter cannot be seen directly, and is somewhat of a mystery in modern-day astronomy. But there is a trick astronomers can use to find out its location. By looking at the way that gravity distorts light from more distant galaxies, they can work out where dark matter is hiding. This lets the astronomers make a detailed map of where the dark matter is, shown here in blue. Comparing the location of the galaxies, the hot gas and the dark matter, shows that this is not a simple crash between two clusters. By reconstructing the history of Pandora's cluster, astronomers think that it must have formed from 4 different clusters involved in a series of collisions over a period of some 350 million years. That the complex collision has separated out some of the hot gas and dark matter, so that they now lie apart from the visible galaxies. Near the core of Abell 2744, the gas of one cluster has collided with that of another to create a shockwave. The dark matter passed through the collision unaffected. In another part of the cluster, there seem to be galaxies and dark matter, but no hot gas. The gas may have been stripped away during the collision, leaving behind no more than a faint trail. Even stranger features lie in the outer parts of the cluster. One region contains lots of dark matter, but no luminous galaxies or hot gas. A separate, ghostly clump of gas has been ejected, which precedes rather than follows. Puzzling arrangement may be telling astronomers something about how dark matter behaves and how the various ingredients of the universe interact with each other. Galaxy clusters are the largest objects in the universe to be held together by their own gravity, and understanding how they form and evolve is a vital aspect of unraveling the history of the cosmos. Learning more about dark matter not only furthers our understanding of clusters, but it also takes us a little closer to fathoming the nature of this mysterious and elusive substance.